Hey everyone, so for this video, what we're talking about is compound interest. So this is example E. It's like we've been doing, but the big difference is we're doing it n times per year. Right? Before we were only doing it once per year, now we're going to do it multiple times per year. We're going to change how many times per year. We're going to do 3 different versions over the next couple of videos. Now the first one I want to do with you guys is doing it quarterly. Now quarterly, in other words, every 3 months, so 4 times per year. Now in particular, we're going to have $500, and again, it's 12%. Now that's the annual rate. If we don't say otherwise, we're assuming that's the annual rate. We're going to do this for 2 years. So what you're going to see is something that looks like this, right? So we're going to have, over the course of a year, right? So we're going to have 1 year, we're going to have 2 years, but rather than splitting it up into the full year, we're going to actually, every 3 months, reset our loan. So what's going to happen is, we're going to start, right, with $500 here. We're going to come over here after 3 months, in other words, the first quarter, we're going to figure out what our interest was by that point. So it'll come up, and then we'll say, great, we're going to reset, brand new starting point. We're going to do it again. And then it'll increase. Now it's going to increase at a faster rate. Now I'm totally exaggerating this, right? This is not drawn to scale at all. But just to kind of exaggerate what's going to happen here. We're going to go again, and it's going to go even faster because we're going to have interest on our interest, right? Steeper. Okay, once again, totally exaggerating this. This is not even close to scale. But I just wanted to give you a sense of what's happening as each quarter. Again, this is, the big difference is before we were resetting it every year. Now we're going to do it multiple times per year, right? Now we're going to do one where it's every quarter. We're going to do one where we reset every month. So we're going to do it 12 times for the year. And then finally, we're going to end up doing it every single day. So 356 times per year. We're just going to compare the results for those 3 situations. Okay, so let's get a little more into detail. Now, if you remember from some previous lessons, when we compound interest, right, the whole point is we are resetting after every compounding period, right? So we had this example, we reset, it's like a brand new loan, new principal. We start calculating the dollars per day based on this new amount. Same thing happens here. Boom, 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 over and over again, right? Now, if you do it once per year, we have this exponential growth equation, right? So this equation right here, we're going to compare these two, right? So this is the really simple version with exponential growth. This is pretty generic. You start with a value, 1 plus, and then the R is the rate of change in percent. T is how many times you do it. And again, that works for interest. It works for if you've got bacteria that are growing. If you're looking at decay, radioactive decay, it's like it with that. The only difference is R is negative. So this is a pretty generic equation, just slightly different variables. What we're going to do now, though, is this is a little more, there's a little more going on here, because now we're going to talk about doing this n times per year. Now, because of this, we have to divide R, because normally interest rate is specified per year. So we got to divide it by n. In other words, so that it's lower. But because we're also doing it more often, the t has to increase by that same amount. So this n is the big difference from what we've been doing. Now, the math is very similar. We just have to reconsider how we use it, right? So again, now we're using R over n and n over t. So the big difference is that if we had 12% per year, but we're compounding it quarterly, then what's going to happen is that means it's, as a decimal, 0.03 per quarter. Now, more generically, I'd say, what's the interest per period? And again, notice I've done interest as a decimal, because when we calculate, we're going to use decimals. We're not going to use percent. Now, there's this new variable n we have, right? This is the periods per year. We use that to figure out these values. Okay, and then finally the total number of periods. Well, you take the number of years, 2 years, times 4. That means we're going to do it 8 times, right? So what's interesting is one thing gets smaller and the other thing gets bigger, right? The interest gets smaller, but the number of periods gets bigger. So they sort of counterbalance, although in the end, the total value is going to be a little bit more because of this compounding effect. All right, so let's now just see what this is going to look like, right? Okay, so I've got my equation here, right? And again, our definitions, balance, principal, annual interest rate, all that. But now we've got this newbie here, right? Compounding periods per year. This is the new part, okay? Compounding periods per year, okay? All right, so let's see how this is going to work. What I'll do is, right, B equals, now again, principal is the same, right? We're still starting, we've got $500 interest, right? Oh, and just to clarify, right? Hey, let's look at, this is how it would have been worded. So our friend Evan here borrowed $500 at 12% interest, compounded quarterly. That's how it would have been worded. To the near cent, how much does he owe in 2 years, right? Okay, so we start here with $500. Okay, now the key calculation that we did, which was up here, right? So I've got to figure out R over N, right? Now, again, I'm just making it clear how you would have got this, right? Now, your interest rate is, right, R equals 0.12. But I'm going to divide by N. All right, compounding quarterly means N is going to be 4. I'm doing this 4 times per year, okay? So R over N, 0.12 over 4. And then NT, it would have been 2 times, but see, we're doing it 4 times, so it's 2 times 4. So I end up with, right, 4 times 2, okay? So let's kind of simplify that a little bit, right? So this turns into 500, 0.12 divided by 4.03, right? So it says 1.03 to the 8th power. 1.03 to the 8th power. I mean, it'd be as if we said, well, what if it was 3% per year for 8 years, right? Different kind of loan, but the calculation would be the same. Okay, so let's now, I'm going to grab my calculator here, right? Again, on the calculator, depending on what kind of calculator you have, it's going to look a little different, but again, I find it's usually easiest to just start with our, move that light so it doesn't glare so much. I usually find it's easier to start with the power here. So I'd say 1.03 to the power of 8, right? That's this part, okay? So I enter that, and okay, big giant number in terms of decimals. Let's see what that's going to be. So let me just write it down. You don't have to write it down, but I'm just going to write it down just for reference for later. 1.26677. Yeah, 0.2666. Yeah, that's. I'll write a little bit more. 0081. Okay, much more detail than we're gonna need, but that's what we got going there. So there's a little stray mark there. Let me fix that so we don't get confused. That's not a decimal. Okay, let's make sure we don't get confused there. Okay, now you multiply this times 500 equals, all right, so I get a balance of $633, and we're going to round up, right? 38, right? But that guy gets to round up, so it becomes 39 cents. Okay, so that's our first one, right? $633.39. Okay, that's if we compound quarterly. All right, so that was example E. Now, what I'd like you to do is try example F, just like we did, except now compound it monthly. All right, so give that one a try. So do the same thing you did, but rather than compounding quarterly, compound this one monthly. All right, let's take a break and then come back with the answer.